This is Algebra 1, Semester 2. This is the third unit called Quadratics, and this is the 19th lesson. The 19th lesson is on the discriminant practice. It's on creatormath.com under the Algebra tab. You might have to type in creatormath.weebly.com into Google to find it. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. And sometimes I try to show this, not on all videos, but on some of the videos lately I'm trying to show this. Here's creatormath.weebly.com. Here's what the home page looks like. Click on Algebra. That's where all the lessons are. Pass by the vocabulary, get to the Semester 2 table of contents. This should have been copied into your pages 2 through 6 long ago. But we scroll down to this unit. This unit is Quadratics, and we are way down on the 19th lesson in this unit called the discriminant. So here are the pages it goes on in your comp book. Please check the current table of contents, not this video, because it'll probably have changed by the time you're watching this. To get notes, we click Notes. You might have to load it a couple times. Sometimes I do. There, it loaded the first time this time, but if I open this up, I can now expand it. And Quadratics number 19, given a quadratic formula, the discriminant is the b squared minus 4ac. So we'll go over that as we do this, but these notes go in your comp book first, and they provide sort of a foundation for you to then go ahead and do the problems. If the discriminant's positive, there's 2 roots. If it's 0, there's 1 root. And if it is negative, there are no real roots, right? Less than 0 is negative. So here's an example of 2 roots. Here's an example of 1 root, and here's an example of no real roots. There's still a parabola there, but it's not intersecting with the x-axis. That's what less than 0. See how this -7 is the discriminant? Since the discriminant is under the square root sign, we can predict the number of roots based on whether the discriminant is positive, 0, or negative. And remember, a negative under a square root symbol produces a non-real number. Hence, non-real roots, no real roots. Okay, and that goes back to the idea of a real number. Quadratic standard form, ax squared plus bx plus c, and the discriminant is under the square root symbol, b squared minus 4ac. This is just some notes from that day in class, and let's see what we got for the problems and see if we can do some of these. All right. So here's the first one using the standard form format. So ax squared plus bx plus c. This is the standard form of the quadratic formula. Not formula, but in this case could be an expression. And once we put it equal to 0 when we find the roots, then it becomes an equation. Identify a, b, and c for the following. So we want to find out what is the number in front of the x squared. That's what a is. What is the number in front of the x? That's what the b is. And what is the number on the tail here? And that's c. And that follows this format. So all we do is say a equals, what number has to be in front of an x squared to produce x squared? It's got to be a 1. The common mislead is, students say a must be 0 here, but if it were 0, the x squared would disappear. So it's got to be 1 so that we have an x squared in this position. So b is what number in front of the x? Plus 6 equals plus 6. I'm going to put in this sign just so you get the idea that when we have a c equal to a negative goes with it, minus 27. So here it is. 1, 6, negative 27. Sorry. 1, 6, negative 27. 1, 6, negative 27. Now when we get to this one, and they ask us the same thing, a, b, and c, I hope you can go 1, negative 14, positive 48. 1, negative 14, positive 48 are the values of a, b, and c, according to that standard form of this quadratic expression. We've done other lessons on this too, you guys, so I'm going to go pretty quickly here. A is 1, b is negative 14, c is 45. 1, negative 14, 45. 1, positive 2, negative 63. 1, positive 2, negative 63. 1, positive 22, positive 121. 1, positive 22, positive 121. All right, so this stuff you can move through pretty quickly, especially given this is the 19th lesson. We've done a bunch of stuff with quadratics before, both notes for your comp book and problems that you've solved. Given the quadratic formula is x equals negative b plus or minus radical b squared minus 4ac all over 2a, what is the discriminant? So just to write this out once, I'm not going to do it every time, the quadratic formula is x equals negative b plus or minus radical b squared minus 4ac all over 2a. And that's the fastest way I've found to say it. You can say x equals negative b plus or minus radical b squared minus 4ac all over 2a. This, under the quadratic, is called the discriminant. It is b squared minus 4ac. That's it. Now we're going to use the discriminant to explain what's happening with the parabola. If the discriminant is positive, how many roots will exist? 2. So imagine a positive number under the square root symbol. Let's just grab positive 9, right? The real produced, don't we get this equals 3? Yes, but we also get negative 3. We get what's called plus minus 3. Two answers. We get a plus 3 and we get a minus 3. That's what happens if it's square root of a positive number. And why is it negative 3? Just to remind you, how did we get to a square root symbol? We took 3 and squared it and got 9, right? So take negative 3 and square it. You also get 9. So the square root of 9 in algebra has to produce a positive and a negative 3. We don't know which it is. So we get two answers from square root of 9. And so, hence, two roots. So this parabola cuts through and has a root and a root. Remember, a root is another name for the x-intercept, where the parabola crosses or intersects the x-axis. And we call them roots, zeros, or x-intercepts. Okay? If the discriminant is 0, so let's say you have a 0 and you take the square root of it. It can only be 0. So you only get one answer. So this is a parabola that comes down and touches the x-axis in one place. So two roots, one root, and you can imagine if it's a negative number under square root, there's no real answer to this. There's an imaginary number, right? Imaginary. So we get no real roots. This is where the parabola does not cross over that x-axis. All right, so if the discriminant is 0, how many? 1. If the discriminant is negative, how many? No real roots. All right, and I would kind of prefer that this said no real roots here. Probably here, and probably there, and probably there I'd like it to say that. A little bit better answer than 0, right? 0 roots. It's not 0 roots, it's no real roots. Given the quadratic formula is this, and that the discriminant is the portion under the radical, b squared minus 4ac, what is the discriminant for the following quadratic? So all we need to do here is say a equals 1, b equals 6, and c equals negative 27. Now we go b squared minus 4ac. We know that b is 6, so 6 squared minus 4 times a is 1 times c is negative 27. All right, so, and they're kind of mapping it out. Look at this, 6 squared minus 4 times 1 times negative 27. And just to model this, let's do it once. I'm not going to do it every time. Go to our calculator, and let's type it in right here. We've got, let's clear this out. Let's turn the calculator sideways. Can we see everything? There we go. So let's do 6 squared. 6 squared minus 4 times a. And we could put it in. It's 1. It's not going to change anything. Times c. I'm going to put this in a parentheses because it's a negative 127. Negative 127. Does a minus work on my calculator for a negative? Some calculators won't let you use a minus key for a negative. This one apparently does, and mine's an Android, so yours will too. So I get negative, negative, maybe it doesn't. Please hold. Whoops. Okay, I didn't want to do that. Okay, 6 squared minus 4 times 1 times negative 27. parentheses. I don't need two parentheses here. I'm having trouble today. Okay, back up here. 144. I think I put in 127 last time. And let's just try it. Let's take this out and make sure it's a minus. 144. Good. I typed it wrong. I think I typed in 127. And I wish I hadn't erased it. All right. So given the fact that this is a positive number, 144, we're going to have two real roots. That's what we're headed for. All right, given that the quadratic is what it is and the discriminant is what it is, b squared minus 4ac, what's the following? So a equals minus 4, b equals 12, c equals minus 9. b squared minus 4ac. b squared is minus 4, 12 squared minus 4 times a, negative 4, times c, which is negative 9. Look, negative times negative is positive, times another negative is negative. Isn't that great? So let's go ahead and use our same calculation here. Let's just modify it. Let's make this 12. We've got 4 times, let's make this a negative 4, and 9. So this produces 0. When the discriminant is 0, how many are you going to have? You're going to have one real root. So we've got 12 squared minus 4 times a minus 4 times a minus 9 is 0. Check. We verified that. Since the discriminant is 0, the parabola will have one real root, and that's where the vertex just goes right and touches, does not cross over, and is not above. My drawing should make it touch, called this line becomes a tangent in other contexts, right? But it's touching but not crossing over. That is one real root. And that's when the discriminant is 0. So probably, is this an example where the discriminant's negative? I bet it is. Given the quadratic formula and the discriminant of b squared minus 4ac, what is it for this given? A equals 1, b equals minus 3, c equals 4, b squared minus 4ac. So you got b squared is minus 3 squared minus 4 times a is 1 times c is 4. So notice 4 times 4 is 16, and negative 3 times negative 3 is 9 minus 16. So you're going to get a negative number here. You're going to get a negative 7. Right, 9 minus 16. And we could have just plugged it in too, right? We could have gone, let's put this now, be very careful and use a parentheses here to say negative 3 squared minus 4 times 1 times c, which is 4. And there we go at negative 7. Check. So they're going to say this one here. Here's our negative 7. Check. Since the discriminant is negative, the parabola will have no real roots. That's where the parabola is up above the x-axis, does not cross the x-axis, and therefore it is a parabola. It's there. It just has no real roots. It has imaginary roots. One more thing maybe we can do, and kind of curious to do this. Let's try this. Let's go to desmos.com. Let's type in f of x, abc. Let's do f. This is in function form of x, which is just like saying y equals. A little bit differences in terms of how we use it, but let's do x squared minus 3x plus 4. X squared minus 3x plus 4. So notice, there's a parabola, it's there, but it is not crossing the x-axis. We can't define any roots for this, no real roots. And you can go back and type in these two. Let's do this one. I'm curious to show you this one that's got one root down here. Right, and you're typing these in too to verify these. This is minus 4x. Let's do a minus 4 plus 12x plus 12x minus 9. All right, look at that. Oh, and I neglected to show you, I'm glad I graphed it because I'm kind of being negligent here. See the negative? We're going to have now, this is upside down. I'm sorry, you guys. I should have pointed that out. Glad I went back and fixed that. And anytime you have a negative in front of that x squared, that flips your parabola so it's opening down rather than opening up. All right? So make sure you're on the right lesson. Just to cover that really quickly, you should be on Algebra 1. It's semester 2. It is the 3rd unit called Quadratics, the 19th lesson called the Discriminant, and it's on creatormath.com under the Algebra tab. You might have to put in creatormath.weebly.com to find it, all right? Hope this helps.